Now we're going to start with the lens and the mirror formulas. Okay, so when we're talking about the mirror formula, there are certain formulas that we have in the mirrors. Okay, the first is the normal mirror formula, where we have 1 by v plus 1 by u is equal to 1 by f. This is for the mirror. Likewise, you have a formula for the lenses as well. In the lenses, it is going to be a subtraction in here. So if he's mentioning concave mirror or convex mirror, you have to understand what they're talking about, and then you have to do it. Okay, now concave mirror. Okay, now how are you going to substitute the values into this? You have to follow the sign convention. Okay, what are you going to do? You're going to do the sign convention for this. Now the concave mirror will be like this. Okay, it is going to be like this. So if I complete the part of it, it is a circle, and it is going to have, in the circle there'll be a center which is called as a center of curvature. Then this part is also measured as the radius. So half of this distance will be your focal length. Okay, your f will be there here, focal length is going to be here, and then you have your pole in here. Okay, now what's going to happen is, now when I take the sign convention, when I take this sign convention, I am going to take it as the x and the y axis. Okay, this is going to be my y axis from the pole, and this is going to be my x axis. And we already know that this side of the x is positive and this side of the y is positive, this side of the x is negative and this side of the y is negative. Okay, so there are different positions in here. What are the different positions that we have? We have, if we are keeping let's say that if you are keeping your object at infinity, that means if you're keeping the object at infinity, then where is the image going to be formed? The image will be formed at the focus, right? So here if you see the object, okay, the object is taken as v, and the image is taken, sorry, the object is taken as u, and this is taken as v. Okay, so what we are seeing is, if we are keeping the object at infinity, the image will be formed at the focus. Okay, and so it is formed at the focus, it is going to be a point size image, and it is going to be at the focus itself. So here the u and the v both are going to be negative. Okay, even your f is negative, because for a concave mirror, I'm talking about, the f is always going to be a negative value, because it falls onto the negative axis of the equation. Okay, now again, if I keep the object beyond c, that means somewhere beyond c, if I'm keeping it, then what's going to happen? The image will be forming between f and c, and it's going to be an inverted image. So if you can see, the image, the height of the image is going to be on the negative y-axis, and the object and the image both are on the negative side. Even f is on the negative side here. Okay, likewise, if you consider, if I'm bringing the object at c, if I'm keeping the object at c, then the image is also formed at c. Again, the u and the v both are going to be negative in here. Okay, and then if I keep the object between f and c, somewhere between f and c, if I'm keeping it, then the image is formed beyond c. Okay, it will be formed somewhere beyond, after c it is going to be formed again. So u and v are going to be negative. Then if I keep the object at the focus, if I'm keeping the object at the focus, then the image is formed at infinity. Again, we are seeing that the object is going to be, both the image and the object is going to be negative. So all the conditions that we have seen in here, if for a concave mirror, what we see is the v and the u are going to be negative no matter what way you keep it, because always the object is kept on the left hand side of the x-axis, which is the negative x-axis, and the images are also formed on the same side, so it is going to be one part of it. Okay, now going ahead, we have the question given as, an object 4 centimeter in size, that means this is the height of the object, okay, is placed at 25 centimeters in front of a concave mirror. Okay, so they're taking, there is a concave mirror, and on that particular place we have an object which is 4 centimeters in height, maybe this much is the height, and it is placed at a distance of 25 centimeters. So now that question, the pieces of information have been copied down from the question here. In front of the mirror, concave mirror, whose focal length is given as 15 centimeters. And then they are asking, so first what is given to us, we'll write that this is the concave mirror. Okay, now the first, this is the concave mirror that is here. Okay, and then I have the pole here, we have the pole here, we have the focus here, and we have the center of curvature here, right? Now the focal length is given as 15 centimeters, right? So 15 centimeters, this is example 9.2 from your textbook. You can open the question, read the question again and again. So the focal length is 15 centimeters and the center of curvature will be double the distance in here. Okay, fine. Then it says the height of the object. Height of the object h is equal to 4 centimeters. That is given to me already. So the and the distance of the object u is equal to 25 centimeters is given to me. Now where is the object kept? It is kept beyond. If I talk about the center of curvature, double of this, so center of curvature will be 30 centimeters. Okay, where is the object kept? It is kept between C and F. Okay, so between C and F means what is the condition, where will it be formed and how it will be formed? We are going to see that. Now, as I told you, whenever we are taking a concave mirror, what we are going to do, U, V and F, all of them are going to be negative for all the conditions. So this is going to be a negative U. The F is also negative 15 that I have. Okay, but the object is kept on the positive side of the y-axis. Okay, where is the object kept? If I take it like this is the positive side of the y-axis. 4 centimeters, it is kept on the y-axis, so the h is going to be positive 4. Okay, now where will the image be formed? So first we will find out the distance of the image. So formula for the mirror is 1 by u plus 1 by v is equal to 1 by f. Okay, so the v value we do not know, u value I know. I will substitute v plus 1 by minus 25 will come here is equal to 1 by minus 15. Let's take this. It becomes 1 by v minus 1 by 25 is equal to 1 by minus 15. Plus into minus, minus. Then I will send it towards the other side. So it becomes 1 by v is equal to minus 1 by 15. This goes and becomes 1 by 25. We will simplify this by taking the LCM. So 25 and 15, when we are taking the LCM, it goes 5 times 5. 5s are 3s are, then 5 and 3 will be left here. So 3s are. So 5 is a 25, 25 3s are 75 is the LCM. So 75 will come here and we have to multiply by 5 here and multiply by 3 here. Okay, so it is negative 5 into 3, positive 3 will come on this side. It becomes minus 2 by, sorry, this is plus. Okay, minus 2 upon 75 is what you get. Okay, when we try to simplify this, this is your v 1 by v value, no, 1 by v, then v value will be how much? V is equal to, we are going to what we are going to do, we are going to do the reciprocal of it. So v goes up and so also this will flip. So it becomes 7 upon 25, that is equal 75 upon 2, that is equal to 35. Negative sign is there, so negative 35, it is what I get here. Negative 35, no, 37.5. Negative 37.5 centimeters is what will be the v value that I will get. So where is it kept? On this side only, after your center of curvature. Negative you got, so that means it is going to go downwards. This is how the image will be formed. So the mirror has to be kept, or the reflective sheet has to be kept at negative 37.5 on the reverse side of the y-axis at a distance of 37.5 from the pole after the center of curvature, and it is going to be this. What will be the height of the image now? For the height of the image, we have a formula. M is equal to h upon h dash is the formula that I have. Sorry, h dash upon h. Do I know the height of the image? No, I don't know. So we do not know the height of the image, so we cannot use this formula. Instead, for the magnification, what we can do is v upon u. So what is v? It is negative 37.5. And what is your u? Minus 25. The minus will go and it will be 37 upon 25. That turns out to be something, it will turn out to be. But let's take it a little, let's simplify this. So what is it going to be? The h and h is also given, the height of the, it is h dash upon h is equal to v upon u, right? Because the height of the object is given to me. So h dash upon 4 centimeters was given, 37.5 by 25. So I will send this here because I want to find the height of the object. So h dash is equal to 37.5 into 4 by 25. We will start simplifying it with the 5 times table only. 5 5s it will go, 5 37, how much will it go? 5 7s are 35 and 2. 0.5 will come here. Then 5 1s are and 5 1s are, it will go 1.5. 1.5 into 4, 1.5 into 4 we will get 4 5s are 20, 4 1s are 4, 5 6, so 6 centimeters is the height of the image. So it is going to be a slightly elongated image, a slightly enlarged image is what you're going to get from this. Okay, now let's look at another question which is given. To construct a ray diagram, we use two rays of lights which are chosen so that is easy to determine the direction after reflection from the mirror. Choose the two rays and state the path of these rays and reflection from a concave mirror. So they are talking about a concave mirror. Now look at the question. They have been given a direct question. They gave that, they gave all this to confuse the student. The first three lines that is there, this is only to confuse the student. Now they are saying, use the two rays to find the nature of the position of the image of an object placed at a distance. Object is placed at a distance of 15 centimeters from a concave mirror of the focal length of 10 centimeters. Okay, so for a concave mirror, u, v and f are all going to be negative is what we have studied already. Okay, so we are going to place this thing. The object is placed at a distance of 15 centimeters. Okay, and the focal length is this. So I'll redraw the figure. This is the focal length. Focal length is at what, 10 centimeters they said, and the object is placed at so your center of curvature will be 20 centimeters, right? These two things then the object is placed at 15 centimeters. 15 centimeters, the object is placed. Then they are asking me where we are supposed to keep the image formation of this thing. So what am I going to do? I am going to do my 1 by u plus 1 by v is equal to 1 by f. I will substitute all of this. So when I'm substituting it, 1 by v, I don't know, that is going to remain. This becomes plus 1 by negative 25. So object is 15 centimeters distance. No, minus 15 is equal to 1 by negative f. Negative f is minus 10 will come. We will simplify all of this to get your v value, and the v value, when it is simplified, it is given as minus 30 centimeters. So that is kept after the center of curvature, 10 centimeters after the center of curvature. Okay, fine. Okay, so we get minus 30 centimeters we got. Then after that, he is asking me to find, he did not ask anything, but he said like what will be the size of the image and all. So the formula is m is equal to v upon u. Okay, because this is negative v upon u is the formula for it's a concave mirror or for anything, negative v upon u. So negative v is minus 30. Minus is already there. This is also minus 30. So put minus 30 divided by your v value you're going to get. V value is minus 15. So this minus gets cancelled. Ones are twos are. So it is minus 2 centimeters. Minus 2 centimeters means it is an inverted image. It is going to be down and it is going to be a 2 centimeter height of the image will be there. Okay, so only with this minus 2 centimeters, what is going to happen? The height is not going to be minus 2 centimeters, but actually the image, this is the magnification factor. Magnification factor you got here. Okay, so with this magnification factor, what is going to happen? If whatever the size of the image will be, if suppose the size of the image is 10 centimeters, supposedly the image will be double the size. Minus 2, minus because it is downwards. 2 means magnification factor is 2. It is 2 times going to increase. So it is going to be an enlarged image. Okay, it is going to be on the negative side. It is going to be a real image because yahin pe ban rahi hai wo, and it is going to be inverted and double the size is what you're going to get. This is not also 2 centimeters. This is centimeter and this is centimeter. No, they will get cancelled, both of them. Now, okay, going ahead with the next question, it says that a student wants to project an image of a candle on a screen of 80 centimeters. On a screen 80 centimeters in front of the mirror by keeping the candle and so conditions. Which type of mirror should the student use? Okay, a screen. So whatever the mirror is, this distance from this is 80 centimeters. Okay, the image is supposed to fall here. The total distance is this. Somewhere here the mirror is kept. Which type of mirror should the student use? Find the magnification of the image produced. Okay. The candle flame at a distance of 20 centimeters from its pole. Okay. So, he did not mention over here that what kind of a mirror. Okay. 80 centimeters in front of the mirror. In front of the mirror means it is going to be obviously a concave mirror because the image is formed on the same side where the object is kept. So it is in front of the mirror, we say. Okay, behind the mirror means if ever they say the image is formed behind the mirror, then we are talking about the convex mirrors. What are we talking about? We are talking about the convex mirrors. Okay, so the magnification of the image produced, you have to find that. The object is kept at a distance of 20 centimeters. 20 centimeters object is placed. So we are going to use a convex. So this is your V, this is your U. You have to find your F. Also, if in case they say to find the F, but they're not saying which type of mirror, concave mirror. Find the magnification. Magnification is M is equal to negative V upon U. So negative V is negative 80 and this is negative of negative 80 because this is on the negative side. You have to follow the sign convention always, divided by the 20. So 0 0 gone, negative 20, negative negative gone. So it is going to be negative 4. 2 ones are 4s are no. So it is going to be negative 4. You will get the magnification. So the image is going to be inverted. Negative means inverted and it will be 4 times the size of the actual image. Okay, whatever the object is, 4 times of that object it will be there. Find the distance between the object and its image. Distance between the object and image. So what we are going to do, distance if you are supposed to find between the object and the image, you are supposed to do V minus U, that is 80 minus of 20, that is equal to 60 centimeters. Here you are keeping the object here, the image is formed here at 80 centimeters. So this distance is 60 centimeters. That's what we calculated it. Okay, next draw a ray diagram in the case in you're supposed to form it like this. So ray diagram means the object is kept over here and you're going to invert it, so it is going to be 4 times, means it's a very big enlargement. So this is how you're going to redraw the figure for this one, the normal figure where the object is kept between the focal length and the center of curvature. Okay, that's what you're going to do here. Now, moving ahead, we have this question over here. Suppose you have 3 consecutive mirrors. Okay, they are talking about 3 mirrors, 1, 2, and 3 mirrors are there. And then it says that the focal length of the 3 mirrors is 10 centimeters, 15 centimeters, and 20 centimeters. Okay, the first focal length is 10 centimeters. Okay, the second focal length is 20 centimeters, and the third focal length is 30 centimeters. Okay, fine. Okay, for each concave mirror, you perform the experiment of image formation for 3 values. For each mirror, you're going to use the 3 values of the object distance of 10 centimeter, 20 centimeter, and 30 centimeters. You're going to keep the object at 10 centimeter, you're going to keep the object at 20 centimeter, and you're going to keep the object at 30 centimeter. Yes, Enara. And you're going to see the image formations. Likewise, for this one at 10 centimeter, 20 centimeter, and 30 centimeter. For this one, 10 centimeter, 20 centimeter, and 30 centimeter. This is actually 15, not this, sorry. 15 and 20 is there. Okay, so this is how you're going to perform the experiment. Now this says that for the 3 object distances, identify the mirror which will form an image of the magnification -1. Whenever it is talking about of equal magnification, the condition is U should be equal to 2F. Okay, the distance of the object and should be equal to double the focal length. So we will write this as a condition in here. How we will write it? We'll write it like this. 1 minute. Okay, so there are 3 mirrors. For mirror 1, which is given as 10 centimeters, there is mirror 2, which is 15 centimeters, and mirror 3, which is at 20 centimeters, is given to me. And then you're placing the object at 10 centimeter, 20 centimeter, and 30 centimeters. Okay, so I said you for magnification is equal to -1. There's no magnification actually, exact same size with an inverted image is being formed. So what kind of a mirror it is? Inverted images means it is always a concave mirror we are having. Okay, now so the condition for this is U is equal to 2 times of F. What is the distance here? If I keep it for F1, if I keep both of them at the same, F image is kept at this one, nothing is going to happen, no magnification will be there. Okay, point size image you're going to get. 2F should be there. Whatever the 10 should be double of 2. If this is 10, the focal length should be double. So this experiment you can see U1 with F3 focal length you can get. Okay, because this is the double of this. U is equal to 2 times of F. Also you can get it when you have This is the only condition where you're going to get this. Okay, u should be equal to 2f. Fine. Then the next question it says is, out of the 3 mirrors, identify the mirror which would be preferred to be used for shaving purposes or makeup. That means we want a magnified image, right? For the magnified image, what we can do, we can use the 15 centimeter or the 20 centimeter, because focal length is 10 centimeter means you can have to keep it very close, no? So we have to have a little farther distance. So 15 or 20 centimeters we can keep it, so that it gives me an erected and magnified image. The face will, you know, look proper when you are looking at it. 10 centimeters will be too close to the mirror. Okay. Now, after that it says, for the mirror B, draw a ray diagram. Mirror B, that means 15 centimeter, for the image formation of an object distance 10 centimeters and 20 centimeters. For mirror B, 10 centimeter. Mirror B, 10 sorry, the focal length is 15 centimeter, object distance is 10 centimeter and 20 centimeter. 10 and 20 centimeters, you have to draw the pictures or the ray diagrams. And so the ray diagrams goes like this. Okay, it is kept between the focal and this, we have the object, and the image will go back and come front, and it is going to be a point size image at the center of curvature. For 20 centimeters it is kept, this is 15, after 15 it is kept, right? 15 means 20 means it's just kept here between C and this. So it is going to be an elongated inverted image. It is going to be an enlarged image is what you get. Okay. Now, okay, it says to construct the ray diagrams, that is the same type of a question. List 2 rays are supposed to be there. You are going to use that ray diagram and all. This is the confusion part they will be giving. Then it says a concave mirror produces 3 times its magnified image. So the magnification is given. Concave means it is going to be a -3 magnification, 3 times the original. If the object is placed 20 centimeters in front of the object, u is equal to 20 centimeters. U will also be negative because it is a concave mirror. How far should be the screen? So m is equal to minus v upon u. M is given as -3 is equal to minus v upon u is going to be minus 20. Okay, so I'll send it here. -3 into -20 is equal to minus v. So I get it. I have to keep the image at, sorry, the image will be formed from the pole. You will get it as 60 centimeters. What is this? This is where the image will be formed from the pole. From the pole distance is -60. But where did you keep the object? You kept the object at -20 centimeters. No. So the image from the object will be at 40 centimeters. That's what he asked. Screen from the object. So you have to subtract these two and you have to give it as 40 centimeters for this one. Okay, let's look at this question now. It says that an image of a candle flame placed after a distance of 30 centimeters from the mirror. This is the mirror, 30 centimeters. I'm keeping it. Okay, placed, and since this particular thing informed on a screen placed in front. Now the screen is also kept in front of the mirror. Okay, object is kept in front, the screen is also kept. So I told you in front means it is going to be a concave mirror. Okay, the screen is placed as 60 centimeter. V is equal to 60 centimeter is what you have. The distance is given as 30 centimeter, that is given. Okay, what is the nature of the mirror? Nature of the mirror, in front means concave. Focal length you have to find. You have to use this formula. Substitute everything because this is a concave. Both of them are going to be negative. You get your focal length here. That goes as, after that magnification you are using. Height of the flame is 2.4. So the object flame is given as 2.4. Okay, so the magnification is equal to height of the image by height of the object. It is also equal to -v upon u, isn't it? So the height object is 2.4 is equal to v is negative of -60, -30. This is gone. Hi is equal to -60 into 2.4 by 30. 0, 0 gone, 3 ones are 2s. So it becomes -4.8. -4.8, you get it here. Okay, that means it is downwards image. It is slightly enlarged image. Okay, that is what you get about it. Okay, now again another concave lens mirror is given. Find the size and nature of this. Okay, so we have find the size, nature and position of the image formed. Object size is 1 centimeter. Okay, height of the object is 1 centimeter. Is placed at a distance, that means u is 15 centimeters. Concave mirror means it becomes negative 15 centimeters. The focal length is also concave mirror, so minus 10 centimeters is what you will give here. Then you are supposed to substitute it into this so that you get your v value. Once you get your v, he asked the distance you will get, position you will get from v. Then nature and size you will get by magnification. M is equal to height of the image by height of the object is equal to negative v upon u. So you simplify height of the image, negative, inverted or erect, you will find out by the sign that you will get for it. Okay, so this is what you're going, it is going to be height of the object will be 2 centimeters, enlarged image, inverted is what you're going to get. Okay, so this is how you do the questions that you have. Again, he said that magnification is -1. Magnification is -1 means 2 is equal to u is equal to 2f is the formula you're going to use for this one. Okay, now the image of an object formed by a mirror is real. Okay, again we are using a real inverted image, inverted concave mirror we are using again. Real inverted image is concave mirror. Magnification is given. If the image is at distance of u is equal to 40 from the mirror, sorry, v is equal to 40 from the mirror, distance of 40 centimeters from the mirror, where is the object placed? U they have to find. Now I don't know the f also in this. Okay, now where would the image be if the object is moved to 20 centimeters towards the mirror? First of all, I don't know anything from this. I know that the magnification is given as m is equal to -1. Because he did not give f, u, I cannot do anything for this. But I have to still find the u. They are asking me find the u. What is the formula? 1 by v plus 1 by u is equal to 1 by f. V I know, f I don't know. U also I do not know. Okay. So I am going to use the magnification. Because he gave magnification, I will use that. Minus v upon u. -1 is equal to, magnification is given, no, -1 is equal to minus v, minus of -40 upon u. So this here minus u is equal to minus into minus plus 40. So u is equal to -40. That means the object is kept at 40. Okay. Object and image are both formed at the same point, -40 and -40. You will get answers like this. So do not worry that my answer is wrong. Maybe v is also 40, u is also 40. You will get it. Once you get your u, you can calculate your f. What did I tell you for -1? This is going to be this. So 2 into f is equal to -40. Then f is equal to -40 by 2. That is equal to 2 ones are and 20s are -20. That means 20 centimeters. Negative means negative sign convention we are taking. This is how you're supposed to do your questions. Okay.